Candu, Canada Deuterium Uranium Reactor. This is the constructional diagram of Candu reactor. A basic difference between Candu reactor and a light water reactor is same water serves as both moderator and coolant, whereas the moderator and coolant are kept separate. Consequently, the pressure vessel of light water reactor, the Candu reactor vessel, contains relatively cool heavy water moderator, does not have to withstand a high pressure. Only the heavy water coolant circuit has to be pressurized to inhibit boiling in the reactor core. Reactor vessel and core. The arrangement of different components of Candu reactor is shown in figure. The reactor vessel is a steel cylinder with a horizontal axis. Length and diameter of typical cylinder is 6 meter into 8 meter. The vessel is penetrated by 380 horizontal channels called pressure tubes. They are assigned to withstand a high internal pressure. The fuel in the Candu reactor is normal uranium oxide as a small cylindrical pellets. The pellets are packed in corrosion resistance zirconium alloy tube, nearly 0.5 meter long and 1.3 centimeter diameter to form a fuel rod. The relatively short rods are combined in bundles of 37 rods and 12 bundles are placed end to end. The total mass of fuel in the core is 97,000 kg. The Candu reactor has several types of vertical control elements. They include a number of strong neutron absorber rods of cadmium, which are used mainly for reactor to shut down and start up. In addition, there is other less strongly absorbing rods to control power variation, heat distribution throughout the core. In an emerging situation, the shutdown rods would immediately drop into the core, followed if necessary by the injection of gadolinium nitrate solution into the moderator. Steam system. The respective ends of the pressure tubes are all connected into inlet and outlet headers. The high temperature coolant leaving the reactor passes out the outlet header to a steam generator of the conventional inverted U tube and is then pumped back to the reactor by the way of inlet header. Steam is generated at a temperature of about 265 degrees Celsius. There are two coolant outlet headers, one at each of the reactor vessel corresponding to the opposite direction of coolant flow through the core. Each inlet header is connected to a separate steam generator and pump loop. A single pressurizer of the type used in pressurized water reactor maintains an essentially constant coolant system pressure. Advantage: enriched fuel is not required. The reactor vessel does not have to withstand high pressure vessel. Only the heavy water coolant circuit has to be pressurized. The moderator can be kept at low temperature. Heavy water is used as a moderator, which has high multiplication factor. Site construction requires less time. Disadvantage: heavy water is very costly, leakage problem, very high standard of design, manufacture and maintenance are needed, reactor size is extremely large. Thank you.